All right, so I asked you to dump out all your contents in the middle of your desk. We're going to go through part for part and double check that you've done everything right so far. I can't be sure until I do the installation check, which I will be doing before you solder. And even then, I'm not going to be able to check all, 40 parts, how many parts we have here. I'm not going to be able to check that for every single person. What I'm going to do is look for some common mistakes. And I'll bet you some people in here have already made some common mistakes. So I'm going to go through part for part, and you're going to check and make sure everything's in the right place. I can tell you already, one of you is lacking a switch. I found this in with the magnets and the clamps. So who is missing their little black switch? It looks like this guy here. Who's missing that? It should have been installed right here on the edge near that white dealie, the variable resistor. Who's missing this? I checked these three. All have them in there. All right, so everyone has this then? Okay, well, don't ask me later. All right, first parts we want to check are all the resistors. I'm going to put them up here as I call them out, and you're going to check the colors. You know that the colors may be a little different for a few of you because we had some different versions that have different color code keys. R1, that would be this one right here. This one right here should be a 100 ohm resistor. Yours probably has a whole bunch of bands, like brown, black, black, brown, something like that, or red. Go get it. Brown, black, black, brown, black, yeah. So if you got a whole bunch of bands and most of them are brown and black, and you probably have the right one. That goes right there, R1. R2. Oh, I've got it right here, Chris. R2 is a 22 k ohm resistor, and that should be red, red, orange. That's R2 over here, red, red, orange. Okay, or you might have one of those greenish colored ones that have brown, brown, black, red on it. Either one of those would be fine. R3, which is right above R1 here, should be a 68K resistor. That's blue, gray, orange. Blue, gray, orange. And remember, on all the ones that had the 4 bands, I wanted you to put the gold band to the right. If it goes sideways, the gold band should be to the right. That'll make it easier for me to check them later on. Next, we have the variable resistor was R4. Yours was white. This one's blue. That was the one you had the hard time bending the wires back on. Okay. We want to make sure that thing's in there properly. If it wiggles a great deal and wants to fall out quite easily, then you need to bend that over better. And all I did is I just used the end of my pin or the pin cap and I pushed it towards that edge. The other two bend over easily. But you've got to hold it firmly from the other side, okay? And bend it towards the edge. Next, we had R5, which is an 11K resistor. It should be brown, brown, orange. That was this one here. R5 goes right next to the variable resistor. And I asked you to put the gold band facing down. Now, Hector, I had to do a little trickery with yours, so that's why you have 2 resistors side by side. Just a little trick so you know. He needed to have an 11,000 ohm resistor there. I didn't have any more 11,000 ohm, but I had 2 22,000 ohm. What happens when we hook up 2 22s together side by side like I did here, we get 1 11. That's the interesting thing with the resistors. When they're the same value and you hook them up in parallel, you get half the value. So I was able to make you an 11K ohm resistor. All right, then all the remaining ones are 6, 7, 8, 9, and 10 should be orange, blue, brown. 360 ohm resistors. Orange, blue, brown. So our 6 is here, our 7 is over here near the front, and 8, 9, and 10. 8, 9, and 10 are here. The gold band should be down, or if it goes sideways, should be to the right. Taylor.
One of mine is the same colors, it's just that the band is different.
That's fine. Different manufacturer, yes.
No, because R5 is blue.
The background is blue? Yeah. You can see on the one I have here. Yours is probably the same as mine. Looks like that one, huh? Yeah. You know, these are used less often. They're harder to read the colors on when you got a colored background like that. You know, the tan background makes reading the colors much easier. So yes, that's fine. I forgot to mention that. For R5, some of you may have had, I guess I did say that, a brown, brown, black, brown, brown, black. And that's fine. Okay? All right. All the resistors are right. Hopefully you've checked those. The next item we added was the IC. That's this part here. Second period, Mrs. Roberts was in here. She checked, and no less than 5 students had put this in the wrong way, which surprises me after all the times that I reminded you how it needed to go in. What are we looking for? The notch. The notch should line up with the notch on the board. 5 people that class put it in upside down. Remember I told you to hold that down and then bend the wires away from one another, and it should be in there pretty firmly and not wiggle. Of course, we're going to be permanently attaching it with solder when we do that part, but it should be in there solidly right now if you follow my directions. Okay, the next part were the 4 transistors. What I'd like you to check for on those is, first of all, look at the numbers. All of them should have what number on them? 7,000. 2N 7,000. So check the face, the flat side of each of these, and make sure it says 7,000 on it. If it says LM something, you've got it in the wrong place. These 4 transistors should all say 7,000 on them.
What's a transistor?
Transistor is an electronic switcher amplifier. Remember we had that on the test? So all these should face to the right.
I can't remember what the...
Taylor, remember? Those 4 transistors are going to be switches to turn on the 4 lights. We'll talk more about how the circuit functions later. Yes?
I can't remember what the circuit part that is. It's filled with an electrolyte that charges up.
A capacitor stores the charge.
Yeah.
No, we don't have any capacitors in this circuit, which is kind of unusual. Usually you do have capacitors in circuits. This one doesn't require it. Although there might be some miniature ones inside this integrated circuit. All right, next, after our, back to the transistors. I don't want to forget a couple things. I told you to look for the flat side. Make sure that the flat side lines up with the flat side on the board. So the flat side should be facing the D. And I also want you to look for the middle wire. That middle wire, and I had to fix it on some of yours already when I was looking at them. I didn't fix it on all of them, just one that I was messing with. This middle wire should be going to the back hole. So the one farthest away from the face of the transistor, the middle wire should be in the back hole. Check that. Also, remember I told you to not push those all the way down, that you should leave it as far away from the board as that black part is tall. That far away, as long as that is. Okay? Alright, after the transistors, the next part was the voltage regulator. The voltage regulator changes the voltage. We'll talk more about it in just a sec here. And it looks like a transistor, but it is not. Inside it is totally different. It's actually an IC in the same package as a transistor. I know it's an IC because I can read off the number and it says LM. And whenever they say LM, that's not a transistor, that's an IC. LM, what is it, 78L, something like that? Is that what it says?
Yeah.
Check yours, make sure it says LM on it. Shouldn't say 7,000, that's the wrong thing. And again, that middle wire should be in the back hole, and you should have left it off the board. If you forced it down, and some of you did, those wires may touch. If these 2 wires touch, or those 2 wires touch, it isn't going to work, guaranteed. Okay? So that's our voltage regulator. Next, we had the diodes, the 3 diodes. Okay, I pointed out that they had to have the black band to the left. That follows the white band that you see on the board. White band on the board, black band on the diode. They should line up. So all the black bands are to the left. After the diode, we did the variable resistor or pot. Yours happens to be white, like this one. And that was the one we had difficulty bending the wire back on. Hopefully you've got that now. Okay. Next, we have the switch. The switch had 4 wires that came through on the other side, and I told you to bend them back like you see here. 2 towards the edge, 2 away from one another sideways. Okay? You're kind of going with the way that wire is already shaped. If you did that properly and you bent them down firmly as you held this down, that switch is not going to wiggle. It's going to be in there pretty darn good. All right. So that leaves us with the LEDs. These are the last parts we need to install. No, the little black thing I'm going to collect from you. You're going to install that at a later date. That goes on after a bunch of other stuff. And I just want to make sure you don't lose it, so I'm going to collect that back from you. So let's take a look at the LEDs, and after we get all the parts in, then I'll tell you how this whole circuit works, because I do want you to understand that. You know that LEDs are diodes, and diodes work like a what?
One-way gate.
One-way gate. They let current flow in one direction, but not the other. Okay? And if you used an LED, let's say for your quiz board, you probably already know. Will it work if you hook it up backwards? No, because it only lets it flow one way, just like a regular diode. So you have to be able to look at these and identify which way they should be installed. And there are some clues to go by. You know what they are, Chris?
Oh, one of the wires is longer.
One of the wires is longer. What else? Look for other clues. You see any other differences? Huh? Taylor?
The inside of
The inside's different, and what else?
Look at the flat things on the wire.
No, not the flat things on the wires.
There's like a S on the left.
Are you talking about inside?
Yeah.
Okay, that was what Taylor said. There's another clue, though. Look carefully. Angelica?
There's like a little part of the LEDs sticking out of it.
Not sure what you mean.
Oh, I know. Big man.
Do you want to?
Flat.
One side's flat, okay? So there's 3 clues about which way to install it. And these are good to know. So I'm going to show you here each one. First of all, here's the first clue. If you look at the LED this way, straight down, the round part is the part that lights up. The bigger part around that is the base. It's a little bit wider down here below. And if you look at the base of it, you will see that there is a flat side. You look at it closely. Do you see the flat side on your LEDs?
Yeah.
Okay, right now it's facing to the right or the left? Right. That flat side, whatever wire comes out on that side, is the negative. That should be hooked to the minus or the black part of the battery. So that's one clue. Also, the wire that comes out on that side will be long or short? Short. So you can look at the length of the wire. And the third clue, well, of course the schematic will tell you which way you should install it, but the third clue is to look inside the LED itself. And you'll see a bigger piece on one side and a smaller piece on the other side. Okay, so that's a clue about which way to install it. Since we already have a finished one here, all we have to do is look at that and see what we did here. You could see the flat side right there is facing to the right, and the right side is the side with the D on it. Okay, so flat side is closer to the D. I want you to watch first, and then you can put yours in. No big rush here. You'd hate to screw this part up. I also want to point out before I put this in that if you look at the wires carefully, and one of you already pointed this out, you can see that there's a flattened section. You notice that? Okay, right there in the middle, the wire kind of flattens out. It's a little different there. Well, that's important too for what we're going to do. I'll show you what I mean. So the flat side goes to the right. That means the long or short wire goes to the right. Short wire to the right, long wire to the left. So I line this up first, and I put in the short wire on the right, and if you put it in, it'll just flop all the way to the bottom like that. We don't want that. We don't want it against the board. We want it to look like this when it's done. So if I let it go down far enough that we get to that part where it flattens out. Then I bend over right at that point. It should perfectly overhang the edge. You see that? It just hangs over the edge of the board perfectly, like that. Now I'm going to hold that in. Watch first and then do. Wait, you'll have plenty of time, guys. Got plenty of time today. When I bend it over, then I'm going to hold it in there and I'm going to bend the wires to the side. Don't bend them up and down. Bend them to the left and the right, like I did there. Okay? Now you can go ahead and do it. Short wire to the right. If you put these in backwards, all of your work is for nothing because they won't light.
So should they at the top and bottom of the middle?
Should what?
Like should it line up at the bottom of the little pieces of the wire?
Oh, the flat part? No, near the top or middle. Yeah, near the, I think it's right, yeah, about. Well, when I say, I don't know what you mean by top or bottom, but you don't put the flat part all the way into the board. If you do, it won't overhang enough. So you put a little bit of the flat part into the board and bend the rest. Okay, as you're doing that, I'm going to go around and collect the Hall effect sensor so we don't have to worry about losing it in the meantime. Nobody will admit to missing the switch. Everybody done? Almost? Chris?
What are those things? The magnet feature?
Come get one right here. Yes.
Is this right, what happened to the,
Left and right.
yeah, electrode?
That's right. That's right. All right, what I want to do here next is give you kind of a theory of operation so you understand how these parts work. I think you'll find it much more interesting and rewarding if you understand and it's not just, blindly following my directions, sticking things in there. It really isn't as complicated as it may sound. I'm going to try to break it down and make this as simple as I can for you. And we're also going to go through and check one more time on the key things. Okay? Last check for the key things. First of all, the diodes. Black line to the left. Check? Check. Okay. The resistors, we already checked those. I'm not going to go through that again. The transistors should have what number on them? 7,000. Flat side to the right. Why does it say Q and not T? T is taken by transformer. You got it. Then we had the IC. Key thing to look for there is notch at the top, okay? And then our voltage regulator here, the flat side to the right, and it should say LM something on it. That's an IC. The transistors and the voltage regulator should not be flat against the board. There should be a little space there. The LEDs should have the notch side on the right. Okay, and you bent the wires away from one another to the side on the back. Okay? All right, I got your Hall effect sensor from you. Now what I want to do is just kind of basically explain how this works. When it's all done, it will look like this one here. You can see the battery pack on the back, and you can see the magnet clamp that we're going to do a little bit with here in a minute. And you can see the Hall sensor that I collected from you. That's that guy right there. The way this works, it starts with the Hall sensor. We got to design the circuit around that sensor. That's like a transistor, but it's specifically designed to pick up changes in magnetism. So when I bring this paper clip, let's say, that has iron, nickel, or cobalt in it, near the magnet, it wants to stick. It wants to stick to that magnet back there. Because the sensor is in between, it can detect that. It can detect that attraction. Just like you can feel the attraction when you bring two magnets close to each other. You can feel it being attracted or repelled. And what this sensor does when it feels that attraction, it changes the voltage that it allows through it. It actually will decrease the voltage. Now, we start with 9 volts. This sensor needs 5 volts. That's why we have this part. The voltage regulator is going to change the voltage. Give that sensor what it wants. Okay? Then the sensor, what it will do is, when it detects magnetism, is it will reduce the amount of voltage that goes through it. It decreases it. Well, we don't want less voltage. We want more voltage. Our goal is to light these LEDs. When you hold down the switch, you want it to, when it gets close to metal, to light up more and more LEDs until all 4 of them come on. That means you're right on top of the metal. If you're a little farther away, maybe 1 or 2 of them light. Get the idea? Well, we want to light LEDs with that. We're not going to be able to light LEDs with less voltage. That's where this part comes in. This part here is called the Inverting Op-Amp. Okay? And I know that's a lot of words, but I'll just give you a basic idea of how this works. To invert means to flip upside down. I just inverted the bottle. Okay? Op is short for operational, and amp is short for amplifier. So picture 2 things happening. Flipping something upside down and making it stronger, increasing it. An amplifier increases. Head up, Matt. The best analogy I can give you, the best explanation for how this thing works, is if you've ever been to those shows like in Vegas, Cirque du Soleil, or at a circus, where they have the acrobats and they have a little seesaw, and they put, someone really light on one end of the seesaw, and then someone heavy jumps on the other end, and that little girl is shot up in the air. You know what I'm talking about? How many know what I'm talking about? Okay, great. And the person that jumps on the one end is probably really heavy. They don't go very far, but the little girl, she goes flying up the other way. Picture that when you think of an inverting op-amp. Because what it does is 2 things. Number 1, when this gets close to metal, it doesn't increase the voltage, it decreases it. So we've got a downward change. We want it to go up. So the inverter takes the down and turns it into an up. Sit up, please. It also only makes a tiny little change. When this gets close to metal, it's just going to be a tiny little change in the voltage. What the inverting op-amp does is it will increase that by 200 times. So a tiny little change becomes a big change. Now do you see how it's like the seesaw thing? The guy going down a little bit on one end makes the girl go up a lot on the other end. That's how this works. Takes a tiny negative change and turns it into a big positive change. Now, if we get enough voltage, we can light more lights. The thing that controls whether the lights, the LEDs, come on are the transistors. So for instance, if one of these is not lighting up, it could be that you hooked it in wrong, or now that you know how the circuit works, you'll go, maybe my transistor's messed up. You could be right. The transistor is going to work like a switch. These are going to switch them on. Now, how do they know when to switch it on or not? Well, that goes to these guys, the diodes. This particular kind of diode, called a Zener diode, they're going to work like a gatekeeper. They're going to decide how many lights come on. And you might go, well, wait a minute, there's only 3 of those and 4 of these. Well, if you think about it, it makes sense. Because when we hold down the button on this, if the circuit's been adjusted properly, 1 light will barely glow. That's just telling me that it's on. And as I get closer to metal on this end, the electricity will be allowed to flow through 1 diode into this guy. It only flows in one direction. Please stop playing with whatever you're playing with. It'll flow through and light the second one. So one of these diodes determines whether 1 or 2 will light up. Another one determines whether 2 or 3 will light up. Kind of acts like a gatekeeper right here. And the third one will determine whether 3 or 4 of them light up. So they're kind of like those people at the rides. You know, Disneyland and carnivals, you have to be this tall in order to go on the ride. Okay? Well, you can get onto this ride, but then another guy asks you, are you taller than that? Then you can go on this ride. Are you 7 feet tall? Then you can go on this ride. So as the voltage increases, these guys let it go through to light more and more and more LEDs. Make sense? How many think they've got a basic idea of this? Okay, good. Now, this little guy is going to be important later on because this is the calibrator. This allows you to adjust the circuit so it's right on the tipping point. It's like me taking this water bottle and putting it right on the edge so it's about ready to tip off. Then it only takes a small little nudge and it goes. Get it? That's what this little variable resistor will let me do. So I'm going to eventually adjust that so that this light barely glows. That way, when I get close to metal, it'll get brighter and the others will light up very quickly. If it's not adjusted properly, I'll have to be right on top of metal before any of them light up. So now you know how pretty much all the parts work. The resistors resist flow and give the different parts the amount of flow they need. Too much flow to the LED, we're going to burn it out. Chris? You having fun back there? Would you get your head up, please? Thank you. So now you know what everything does. Of course, the battery, we know, supplies the voltage. Okay? What we need to do here next, though, is you guys assembled the clamps. Some of you may have done it right, some maybe not so much. The part that the long bolt went through should be which part of the bracket? The long or the short side? The long side. So take a look at your bracket right now and look for these things. First of all, did we put the bolts through on the side with the tape? Some people put them on backwards. You should see the bolt heads on the side with the tape. Coming out the other side, that bolt should be going through the long side of the bracket. You can identify the long side of the bracket because that hole is not smack dab in the middle. It's off-centered. On the short side of the bracket, the hole is right smack dab in the middle.
So the short side should be...
Short side, short screw. Long side, long screw. Okay? Or bolt. So check that. Make sure that they put it on the right way. If you have to disassemble it, then do that. Then, I need you to take out this magnet, so loosen the bracket a little bit, and take out that magnet. We're going to need to determine which side is north and which side is south. I'm going to give you necessary supplies to do that, so wait until I tell you what to do. Okay, so here's how this works. I gave you a permanent magnet that's labeled north and south. And it's hard to see that one, but that said south on that side. You took out the magnet that was in there. You need to figure out which side is north and which side is south. So I just let these two stick together, and I know that if that is the south side of this magnet, then this is the north side, and the one that it's stuck to is the south side. Or put even in simpler terms, when I stick these together, all the souths face the same direction. All the norths face the other direction. So label that other magnet with either an S or an N, doesn't matter which one, so you know which side is which. If you want to label both sides, that's fine too, I don't care. Just make sure your S and N do not look identical. Once you've done that, pass the Sharpie back and the magnet. No, not yet.
How did you find out this matters?
Huh?
How did you find out?
I used another magnet, it was already labeled. That's a good question. All right. In order for this circuit to work properly, we have to have the magnet installed in the bracket the right direction. Now, you may not get back the same bracket. You probably won't get back the same bracket. So down the road, later on next week, when you go to try this out, if you get it done next week, and it doesn't work, you might want to go and check the magnet. Make sure the person labeled it properly. Because if they put it in wrong or labeled it wrong, it's definitely not going to work right. Ruben?
Oh, never mind, I figured it out.
Okay, so all we need to do now is I happen to have labeled this one north, and I know that I want to have the south end closest to my sensor. So I'm going to put it in with the north away from the tape, the south end closest to this side. South end faces this side, the side with the paper and tape on it. One more time. South end faces the side with the paper on it.